Hello everyone. In this video, we are going to evaluate trigonometric functions using the special right triangle, and this is the third part. In this part, the given angle is more than 360 degrees. Before we go over this example right here, let's have a review on the special right triangle and the formulas to find the reference angles. We remember that the special right triangles, that includes the 30, 60, 90 degree triangle and the 45, 45, 90 degree triangle, and the formulas to find the reference angle are very important in order that we can evaluate trigonometric functions. Let's go over the special right triangle here. Let's start with the 30, 60, 90 degree triangle. We remember that the side opposite to the 60 degrees is square root of 3 over 2, and the side adjacent to 60 degrees is 1/2. And the side opposite to 30 degrees is 1/2, and the side adjacent to 30 degrees is square root of 3 over 2. The hypotenuse for the 30, 60, 90 degree triangle is 1. Now let's go over the 45, 45, 90 degree triangle. We remember that the side opposite to the 45 degrees would be square root of 2 over 2, and the side adjacent to the 45 degrees is square root of 2 over 2. And it works for the other angle since both of them are 45 degrees. And we also remember that the hypotenuse is 1. These are the formulas to find for the reference angle. Please remember that this formula would work if our angle is more than 360 degrees. This is the formula to use to determine the reference angle if the angle is on the first quadrant. This is the formula to use to determine the reference angle if the given angle is in the second quadrant. This will be the formula if it's on the third, and this is the formula if it's on the fourth. Okay, going back to the example right here, we can determine the exact value of tangent 405 by following some steps. The first step is to sketch the angle on the unit circle, determine the reference angle, and completely label the special right triangle on the unit circle. So since we are given tangent 405, we remember that in a circle, we start from 0. Then this side right here is 90. This is 180. This is 270, and this is 360. Once we go further, this becomes 450, and then this one right here is 540. This is gonna be 630. This one right here is 720. So we are given 405. So what are we gonna do is, again, one full turn around the circle is 360. So that's 360 right there. Since we say this is 405 and this side right here is 450 and this is 360, so it should be located somewhere in here. And so we are interested to determine the value for this angle right here. And we can do that by solving for the reference angle. So the reference angle, since this falls on the first quadrant, the formula for the reference angle of the first quadrant is whatever the given angle is, which is 405. So we did a 360 turn, and then that's 405 all the way over there. So again, this is 405. So we can go ahead and say that the reference angle for the first quadrant is the given angle, which is 405 minus 360. So in this case right here, if we subtract 405 minus 360 is 45. So our reference angle is 45, meaning this angle right here is 45 degrees. And that makes sense because if one turn is 360, but then it goes all the way to 405, so then this remainder here is 45 degrees. So then we go ahead and label this triangle right here, so we can create the right triangle here. So this is the right angle. We remember that the hypotenuse for this right angle here is 1, and then the side across from 45 is square root of 2 over 2, and then the adjacent side of 45 is square root of 2 over 2. Now let's determine the sign. Since this side right here, which is the adjacent side, is on the positive x-axis, this is positive. And then since this side opposite to the 45 degrees is parallel to the positive y-axis, this means that this value right here is positive. Looking at this, we have tangent. So we're going to use SOHCAHTOA. Since that is tangent, we're going to use the TOA. So we remember that TOA is opposite over adjacent. So we can go ahead and write tangent 405. So that is equal to the opposite. So the side opposite to 45, which was our reference angle, is square root of 2 over 2, which is positive. And then that is over the adjacent is square root of 2 over 2. Dividing this would give us 1. So the exact value for tangent 405 is 1. Now let's move on to the next example. Okay, so we're supposed to determine the exact value of sine 510. So let's label the angles first. So we go over the steps. The first step is to sketch the given angle on the unit circle, determine the reference angle, and completely label the special right triangle on the unit circle. So we are given sine 510. So again, one full turn is 360. So this is 360 right here. But we say that it's 510. So this is 450. So we can go all the way up there. But then that's still 450. We are given 510. And this is 540. So it should be closer to that. So we can go ahead and approximate it to be somewhere around here. So this angle that we have here, the one that I made turn here, the loop that we got over here, this is actually 510 degrees. So that we go ahead and determine the reference angle. As you can see, this is on the second quadrant. To determine the reference angle of the second quadrant, that is actually the value of the closest x-axis, which is 540, minus the given angle, which is 510. So that we can go ahead and subtract this. This would come out 30. So 540 minus 10 is 30. And so this means that this angle right here is actually 30. And that makes sense because if from here all the way to this side, the negative x-axis is 540, but we stopped on 510. That means this angle right here, the remainder, is 30. So that we go ahead and label the measures for this right triangle that we have here. We remember that the side across from 30 is 1/2. And then the side adjacent to 30 is square root of 3 over 2. And then the hypotenuse for the unit circle is 1. Now let's look at the sign for this. Now looking at this x-axis that we have here is on the negative side. So this square root of 3 over 2 is negative. And since this vertical line that we have here is parallel to the positive y-axis, this value here is positive. So we're going to move on to the second step. The second step is to use the SOHCAHTOA to determine the exact value of the angle. Since this is sine, we're going to use SO. So that would be a SO, meaning that sine is equals to opposite over hypotenuse. So we can go ahead and write sine 510 degrees is actually equal to the opposite. So the side opposite of 30, which is the reference angle for 510, is positive 1/2. And then the hypotenuse is 1, because again, that's opposite over hypotenuse. So that we can go ahead and say that the value for sine 510, when we divide these two, is actually 1/2. So 510 is 1/2. Now let's move on to the next example. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. We're supposed to determine the exact value for cosine 600. In order that we can do that, we follow the steps. The first step is to sketch the given angle on the unit circle, determine the reference angle, and completely label the special right triangle on the unit circle. So let's label the angles first on this picture. Okay, since we are given 600, so this is 540, this is 630, so that means 600 should be somewhere around here. So that means if we make a full turn around the circle, that's 360. this is 450, this is 540, and so that means this is 630 if we go all the way over here, but we are supposed to determine the cosine of 600. So it should be somewhere around here before this line right here. So let's just approximate it to be somewhere around here. So this is again 600 degrees. So I'm going to label that as 600 right here. So then we go ahead and determine the reference angle. Since this is located on the third quadrant, we remember that to determine the reference angle for the third quadrant, we are going to write down the given angle first, which is 600, and we are going to subtract the measure of the angle corresponding to the negative x-axis, which is 540. So that would be 600 minus 540. So if we subtract this, this will give us 60. So this means that this side right here is 60 degrees. So I'm just going to label that up here. So that's 60 degrees. So we can go ahead and draw the triangle that we have here. This is the right triangle. We remember that the side across from 60 is square root of 3 over 2, and the side adjacent to 60 is 1/2. Now for the signs, we remember that this is on the negative x. That means that this is negative, and this one right here is parallel to the negative y-axis. So this side right here is negative, and remember that the hypotenuse is 1. Now we move on to the second step. Use the SOHCAHTOA to determine the exact value of the angle. So we are given cosine, so we are going to use the ka. Ka means adjacent over hypotenuse. So we can go ahead and write cosine 600 degrees would be equal to adjacent is negative 1/2, and then the hypotenuse is 1. So negative 1/2 divided by 1 is negative 1/2. So the value for cosine 600 is negative 1/2. Did you get the same answer as this? Good. Perfect. Now let's move on to the next example. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. Again, we're supposed to determine the exact value for tangent 690. So we're going to label the angles first. Now we're ready to move on to the first step. The first step is to sketch the given angle on the unit circle, determine the reference angle, and completely label the special right triangle on the unit circle. So we are given tangent 690. So one full turn around the circle is 360. That's 450 right there. This is 540. This is 630. Now we want 690. So 690 can be approximated to be somewhere around here, because if we go all the way here, that is 720. So this is approximately 690 right here. So I'm just going to label that 690 degrees. And so we go ahead and determine the reference angle. This is on the fourth quadrant. Reference angle for the fourth quadrant is 720, which is the angle corresponding to the positive x-axis, minus the given angle, which is 690. So 720 minus 690, that gives us 30. So then the reference angle is 30. That means this side right here is, or this angle is 30 degrees. So we are going to draw the right triangle here. We remember that the side adjacent to 30 degrees is square root of 3 over 2. The side opposite to 30 degrees is 1/2. And then the hypotenuse is 1. Since this is on the positive x-axis, this value is positive. Now, since this is parallel to the negative y-axis, this is a negative 1/2. So that we go ahead and move on to the second step. The second step is to use the SOHCAHTOA to determine the exact value of the angle. Since we are given tangent, we are going to use the TOA. TOA means tangent is equal to opposite over adjacent. So tangent 690 degrees would be equal to the opposite side of 30 is negative 1/2. And then the adjacent side is square root of 3 over 2. Since this is a complex fraction, we are going to flip the denominator and multiply across. So this would come out, that's negative 1/2 times. Flip this, that would be 2 over square root of 3. So we can cross out the 2 and the 2, so we're left with negative 1 over square root of 3. So we are going to rationalize the denominator since the square root of 3 is at the bottom. So we multiply both the numerator and the denominator by square root of 3 over square root of 3. So this gives us negative square root of 3 over square root of 9, where square root of 9 is actually 3. So then we can go ahead and say that the value is actually square root of 3 over 3, and the value here is negative. So we can go ahead and write that up here. So that is negative square root of 3 over 3 is the exact value for tangent 690. Did you get the same answer as this? Good. Perfect. If you found this video helpful, hit like and subscribe for more math videos. See ya!